All right. Now, yay calculus. And yay cones. Heck yeah. You know you want a cone. That's right. All right. Base of a cone-shaped tank. Vertex of the cone 12 feet above the base. So we're talking about a cone-shaped tank like this. Cone-shaped like this. Vertex is 12 feet above the base. And radius of 5 feet. Tank filled to a depth of 7 feet. And water flowing out of the tank. At a rate of 3 cubic feet per minute. And find the rate of change of depth in water in the tank. So we want dH dt. Alright. So first things first, compliments of Mr. Kenyon and crew know that we got 12 to 5 going on here. So our 12 to 5 equals height to radius. And we want to turn radius in terms of height. So radius equals 5h over 12. Right? 12r equals 5h. So now we have volume equals 1/3 area of the base times the height, which is 1/3 pi r squared h, which is going to be 1/3 pi 5h over 12 squared h. Right, we'll take the derivative of that, so dv dt equals 1/3 pi, that'll be 5, good kitty, 5/12, 5 squared over 12 squared times h cubed, dh dt. And we know this change in volume is 3 feet per minute. So 3 equals 1/3 pi 25 over 144. And that was I take the derivative of that without taking the derivative. That was silly. So that was supposed to, this was here. This is an h cubed, so it should have been 3 times this. And this should have been a squared. Oh, silly man. Right. Right, so that's h cubed, so that'll be 3h squared, and those guys would have hung on the edge. Okay, that's much better. So h, the height was 7, dh dt times 3, and we'll take this 3 and that 3 and get rid of them. So we'll take 3 and divide it by pi, and we'll divide it by 25, and we'll divide it by 49, and we'll multiply it by 144. We should get dh dt. So 3 divide by pi, divide by 25, divide by 49, multiply by 144, and we get 0.11225, etc. And let's change in rate of change the depth of water in the tank. Be 0.112 feet per minute, or it'd be nicer in inches per minute, wouldn't it? .34, 1.35 inches per minute. Okay. Right. Last question. Two boats are traveling towards a buoy along paths that make a 90-degree angle. First boat is 165 feet, so blah, 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 blah. Alright, towards a buoy. Alright, so... there's a buoy. It's got clang, clang thing. Two boats, 90-degree path. First boat is 165 feet, 25 feet per second. And the second boat is 110 feet and 35 feet per second. We're going to change the distance to the boats. Between the boats after 1 second. So after 1 second. I suppose that's one after 1 second. So this okay. So the 1 equals the seconds. All right. So here are our two changing rates. Where we have changing rates, we have changing distances that go in terms of that. So d squared equals 165. No. Okay, substitute in just yet. So let's call this y, this x. D squared equals y squared plus x squared. That means that d dt, d dt equals 2 dt equals 2y dy dt plus 2x dx dt. And where our initial distance what d actually equals would be the square root of 165 no, wait a minute. And the rate of change of the distance between the boats after 1 second. So that means that if we are 165 feet away, after 1 second, we will be 25 feet closer. So this will be actually 140 feet. And this 110 will be minus 35. 110 minus 35 is, come on brain, 75? Yeah, so we're a little closer than that. So we're not 165 feet in one direction, we are 140 feet, because we've gone a second. We'll add that to 75 feet. So our new distance, 158.8 feet. So this will be 158.8 dt plus equals 2 So our y is 140. The change in y is 25. Plus 2 times x was 75. And our change in x was 35. It's curious that they would do it like that. No, I guess not. Alright, so here we go. We're just going to figure all this out. So throw it in the calculator. Alright, so that'd be, everything's got a 2 in it, so I'm not going to bother with those 2's. Got 140 times 25 plus 75 times 35 divided by 158.8. That'll be our new rate of change, 38.57. That'll be 38.57 feet per second. That makes sense. We're going 25 miles per hour, or 25 feet per second, 35 feet per second, so we're getting closer to rate faster than that. So works for me. We're all good. Those. And these. That's it.